Good morning, good afternoon, and good evening, everyone. Welcome to this Agora webinar titled Empowerment Through Openness, the Future of Energy Modeling. Thanks to the audience, the speakers, the panelists who are joining us from all around the globe. And especially I want to thank David, Paola, because you're joining from a very early morning from the Pacific coast of the US, and also Tarinia and Romil. You are both joining from Southeast Asia. So altogether, we have 16 actually time zone, plus the audience. I think we cover really a global outreach. So we are here today to discuss open source energy system modeling and the role it takes in shaping energy policy. I think we all agree that transparent and accessible information are a core principle of evidence-based policy making. It helps build broader consensus around policy choices. And open data and open modeling tools are, in this context, essential for fostering inclusive public debate and enabling better decision making. Open source energy modeling has been evolving considerably over the last 5 to 10 years. And in the policy arena, we see growing demand actually from policymakers, ministry regulators, but also transmission system operator, civil society organization for these tools which are transparent and accessible. We have seen tools such as PyPSA, OSeMOSYS, which have matured significantly. And historically, energy modeling were often black boxes which were locked behind expensive or restrictive licenses. And open source really allow us to actually access much more actually transparent information. And the capability gap between these open source models and the proprietary one, I think, is about to disappear. It's also a trend that we see, which is accelerating in the context of AI or other data-driven revolution. So I think energy models with the underlying data are increasingly becoming a public good, and they are helpful for designing and challenging policy making. So this opens new opportunities for trust, collaboration in energy planning. So this is why today we brought several experts to explore how open source model can become credible and impactful globally. So over the next 1.5 hours or so, we will discuss what open source energy models are, what are the contributions in energy policy making, and look a bit in more detail about the momentum which is happening in this open source modeling community worldwide and what is needed for building a sustainable ecosystem. We will start with a keynote from Professor Tom Brown, and then we'll have 2 panel discussions and the presentation of Agora on the open source PyPSA-SPICE model, which is actually released today. So without further ado, let me introduce you, Professor Tom Brown. I'm very glad you could make it with us today. You're a trained physicist with a postdoc in string theory. I mentioned this because I'm a big fan of string theory. And moving from string theory to energy network, I think there is kind of a bridges. You have been a research group leader for energy system modeling at Karlsruhe Institute of Technology, KIT, and currently you're professor of digital transformation in energy system at TU Berlin. I think you're well known in the community as a creator of PyPSA. Your team has maintained also several packages, including PyPSA, of course, but AtLight, LinoPy, and PyPSA Europe. So also, I want to congratulate you because the version 1 of PyPSA has been released a couple of days ago, and after a decade of development. So this is really an interesting momentum. Congratulations. And the features, the website, the documentation, everything is excellent. So without further ado, I'll leave you the space to give your first keynote. Thanks a lot, Tom.
Thanks a lot, Dimitri, for this very kind introduction, and thank you to Agora also for allowing me to give this talk right at the beginning. So what I'm going to do is I'm going to cover, I hope you can see my slides, I'm going to cover basically a bit of motivation about why open energy modeling is so important, and then I'll go through a few examples where PyPSA has been used, where it's had impact before wrapping up. So just to motivate why openness is so important, I kind of want to also emphasize why energy modeling itself is so special. So energy modeling is simulating our energy system, the future of our energy system in computers, and energy is so central because it's such an important part of our economy. It's the foundation of our prosperity. So it gives us all this access to services, but at the same time, it's also in the middle of several problems that we're facing regarding climate change, air pollution, and resource conflict. There are many commercial interests involved as well, so the spending on energy goes to the many trillions of euros per year, and around $1 trillion of that is actually fossil rents. So we shouldn't be particularly surprised when petrostates start to object when the energy transition eats into some of that demand. So it's a central place where there is conflict, and there are a lot of uncertainties. So whether that's hydrogen cost, the scale up of direct air capture, or what's happening in the geothermal or nuclear spaces, there's lots of uncertainty. And then when we look at cost optimization, we're probably quite well aware there are many other objectives that people have beyond cost. So we care about the environment, we care about public acceptance and land usage. There are difficult political questions about where we do our energy intensive industrial steps and restructuring our value chains. And so given all of this uncertainty and difficulty, we try to anticipate the problems in computer models to try and avoid some of the bad investment decisions that could come about from not anticipating these kind of problems. And that leads us to build computer models, but they're very much driven by the assumptions that go into them, the cost, the demand, and the constraints. And in the past, this has been a real problem because many of the models have been closed black boxes, which prevents real scrutiny of what's going on inside, and of course, offers the potential for future manipulation. So starting around 2014, there was a big movement to push for open energy modeling. And that means that the modeling is done with open source software, with open data. And open here means that anyone can take the code or the data, look into it, modify it, share it with others, and then redistribute the changes. And the way you achieve this openness is by publishing it and then publishing next to it a license which tells the users what their reuse rights are. And the vision of this open energy modeling initiative that was founded just over 10 years ago was this whole pipeline should be open, from the raw data itself, through the processing of that data, through that bundling of the data into the models, the processing inside the models, all of the constraints and everything, and then the publishing of that data as well. So everything is transparent. And since 2014, there's been a real blooming of models. I'm not going to go through all of them, but this is a list that's maintained on the Wikipedia page for open energy models. There are really many of them. And many of them are actually mature. They've gone through many cycles of development. They've been battle tested in studies and research papers. And I'll show a few examples from our model PyPSA in a few minutes. So how does this openness really help? Well, Dimitri's already touched on a lot of this, but it increases the transparency, the reproducibility, and the credibility when you can really show all the workings behind your study. So we're trying to avoid black boxes that are determining trillions of euros of spending. And by allowing openness, it allows many people to collaborate on the tools and share the tools. And that reduces this duplication of effort that we see when every single research institute and modeling shop has its own model. There are really hundreds of models in Europe that are being used for policy analysis. And if we were sharing those resources, we'd free up lots of time and money to develop new ideas. That's what we want to focus on, innovation and new ideas. And openness allows innovation because it allows a high level of customizability. One of the main reasons people choose open source tools is that you can go deep into them and modify them very easily, which may be difficult inside a commercial tool. And the fact that these tools are freely available, are low cost, enables new actors to participate in the debate. So we've seen a lot more participation by NGOs, for example, in energy discussions because they have these tools which allow them to cross-check the studies done by others. This brings benefits as well. By having open tools, it avoids lock-in, where people get locked into software or get locked into particular consultants using the software. When it's open, you can easily switch from one tool to another or from one vendor to another. Allows collaboration, and the cumulative effect, which is very important, what Dimitri also mentioned, is it increases the public acceptance of some of these difficult trade-offs that we need to make on the way to the energy transition. So I actually sketched this slide around 5 years ago, a sort of long-term utopic vision of what this open ecosystem might look like. And we're kind of getting there. It's kind of nice that after all this time, we're getting close to this vision where you'd have a sort of set of open models that are respected and trusted by many different people from industry to academia So you could imagine a situation where a grid operator uses the model to show that network expansion is required under this and this assumption. Maybe an academic comes and shows that some grid enhancing technology could help to reduce some of that investment spending. The regulator takes notice and adjusts the incentives to allow this kind of instrument to be used. And then maybe an NGO comes in and says, well, hey, if you have stronger efficiency measures here, you could reduce the build out of onshore wind in this area with a high level of bat and bird diversity. And then the government takes notice and makes the adjustment. And through this interaction in this open source ecosystem, the public confidence in the energy transition can rise. And originally on this slide, I said this is not possible in the current ecosystem, but actually I think it's got better. We're not there yet. I'd say it's only difficult right now because many of the models are still closed and black boxes, and there isn't really that comparability there. So that's the kind of vision. That's some of the procedural challenges. There are, of course, other challenges when we move to a more strongly renewable system and a deeply decarbonized system. And that's really to motivate why we develop PyPSA. So we have this very high level of variability from wind and solar, that they're varying strongly over time. They're varying also strongly in space. So we have different wind conditions in different locations. That motivates really good grid modeling, so we can see how we can balance wind across the continent and move the wind from Western Europe to Central Europe, depending on the wind conditions. So we have challenges on the modeling side from this variability, and we also have challenges on the demand side from the need to electrify many of the sectors. So you can see here a nice graphic from Ember about global final energy demand, and only about 20% of that is currently electricity. So decarbonizing that is only part of the step. Another big part of decarbonization is electrifying those other sectors like space heating and land transport and industry, so we can then decarbonize those sectors with our renewable or clean energy. And that is the overall challenge that we were trying to fix by introducing Python for power system analysis. So I'll switch over now to give a little bit of an overview of PyPSA. It's an open source tool, so you can go onto GitHub and download the model and run it. And it's trying to fix this gap between power flow software like Power Factory or Mad Power and this more energy systems world like Plexos, Times, and OSeMOSYS, to bring these worlds together, because we realized that you need this very high resolution in time and space to get that integration of renewables and flexibility together, as well as this high levels of electrification of transport, heating, and industry. That need to model the variability and the flexibility motivated the tool to do this kind of high resolution modeling that we see as necessary. And so PyPSA has a lot of features for capacity expansion planning, so building new capacity, market modeling, power flow, with different components for everything that you might need for AC and DC networks, generators, variable generators, and all those power to X technologies that might be needed in the future. And as the name says, it's running on a very popular programming language, PyPSA, with a whole load of open source libraries in the backend. So it's really building on this open source system that's already there in Python. And we've made some adjustments. So Fabian Hoffmann, for example, from Open Energy Transition, developed LinearPy when he was back in my group to make the solving go faster. And then we integrate to all those various different solvers and give you access to all of the visual information using these Jupyter notebooks. So rather than show you what we do with the tools, one more thing. We also released, as Dimitri said, our version 1.0 just a few months ago on its 10th birthday. And this is really taking PyPSA into the very mature area where it can tackle all the kind of problems that you can tackle with commercial tools. So we have here, for example, stochastic optimization over uncertain variables, risk-averse optimization, and a series of changes to improve interactive mob mapping, documentation in the backend. So rather than show you what we've been done with the tool, well, I like this quote from Rufus Pollock, the founder of Open Knowledge Foundation, that the best thing to do with your data or software will be thought of by someone else. So I think this is really true for PyPSA. The most impact that PyPSA has been other people taking the tool and applying it to their own problems where they know the problem the best and can find the best solutions. So I'll run you through a few examples. We have many worldwide users, so I'll try and give a bit of a selection. So one of our first really commercial users was a transmission system operator in Southwest Germany, TransnetBW, that took our European model and applied it for trying to understand the decarbonized system in 2050. And their motivation was really, it was easier to take an existing model rather than trying to reinvent the wheel themselves. They were saving time, and they had a model and were ready to go and could focus on what they really wanted to do. We've also seen usage now by Agora, used a very similar model that they adapted to look at the benefits of cross-national and cross-sectoral coupling. This was published a few weeks ago and identified savings there in the European system from over 500 billion euros until 2050. We've seen other institutional take-up, for example, by the International Energy Agency, who's represented today by Anthony Vautrin, who's been doing studies for the World Energy Outlook. And here is a country study for Vietnam, looking at integration of solar energy. And on the European side, with the Joint Research Centre of the European Commission, has been using PyPSA Europe model for their studies, first in 2024 on redispatch, study that got heavy billing in the Draghi report, and also a recent study a few months ago on locational price signals, how they can help reduce consumer spending. So you can see on the right graphic, everywhere which is dark blue, sees significant savings in consumer spending. It's also been picked up by ACER, the European Association of Regulators, for their EU-wide flexibility needs assessment, here being supported by Open Energy Transition, represented by Marta Fitztaki on the panel today. And they're going to be looking there at methodologies for flexibility. Transition Zero, who's also on the panel today, has been focused in various studies in Asia and Southeast Asia with their TZ ASEAN power grid model. We in Germany have been looking at transmission savings. I'm going quite fast now because I'm about to wrap up. And also in India, we've seen early studies by Terry, based out of Delhi, looking at system integration there as well. And beyond these country-applied studies, we've also been doing more kind of conceptual studies, looking at really deep decarbonization futures, how to avoid lots of gas infrastructure, using, for example, liquid energy carriers like methanol. So that's a bit of a rundown of some of the uses of an example of an open source model. There isn't just PyPSA, there's many others, OSeMOSYS, EMMA, OMOF, but it gives you an impression of what's currently being done with the models. So to wrap up, I hope I've convinced you that energy modeling is, first of all, very important. It's a very special field because energy is so central to our economy and many of the future challenges we're facing. Unfortunately, many models are closed and intransparent, and that's a real issue if you want to have reproducible, understandable, and high acceptance for the modeling. Because the models depend strongly on the assumptions and the approach, so it's very important to openly set out what is driving your model results. And the way to do that is to attach open licenses to the data and the code. This gives many advantages, not just to academics like me, but also companies, governments, NGOs, because they can then easily customize the software. They avoid any kind of lock-in from commercial tools or from the vendors, and it increases innovation by allowing everyone to focus on new features rather than these closed models where it's very hard to transfer from one to the other. Unlike 10 years ago, when the Open Energy Modeling Initiative was founded, we actually really have some mature models that have been battle tested in study after study, models like OMOF and OSeMOSYS and Calliope. The one I presented here is PyPSA, where we see this kind of need for this high resolution modeling of renewables, grid, electrification, and molecule synthesis. So I hope that sets up the discussion for later, and thank you very much for your attention.
Thank you very much, Tom, for this framing, excellent framing. We'll move to the next part of this discussion, and I'll leave my colleague, Rena, to introduce the first panel.
Thank you, Dimitri, and thank you also, Tom, for that very inspiring keynote on the evolution of PyPSA so far. We'll now move on to the first panel discussion, the need and impact of open source modeling. We have around 20 minutes, I think, and we have 4 panelists, so let's get started on this. This panel will focus on why is open source modeling so much focus on that now? Why does it matter now more than ever? So it was mentioned that proprietary and commercial modeling tools like Plexos and so on seem to be becoming expensive and rigid, pushing planning bodies to look for alternatives. And at the same time, major institutions in Europe like ACER are now recognizing these open source models as reliable. So we'll explore what's driving this shift and what it means for energy planning globally. I'd like to introduce the distinguished panelists that we have today. And I hope we are all here and we have the video cameras on. So first, Mr. Antonio Lopez Nicolas, Deputy Head of the Renewables and Energy System Integration Policy Unit at the DG Energy from the European Commission. Antonio can speak to how the European Commission sees open source tools for policy development. And then we have Ms. Tarinya Supasa, Head of Sustainable and Renewable Energy at the ASEAN Center for Energy, so from the Southeast Asian nations. And she brings the perspective of a regional energy body navigating these tools. And special thanks for joining us late in the evening from Jakarta. I hope she's here. I don't see her myself. Mr. David Paulela is the next from Research and Analytics at Breakthrough Energy. Also, he's joining us from afar. He brings the funder and philanthropic perspective on why open source matters for accelerating the transition. And then, of course, Professor Tom Brown, who needs no further introduction as he gave that excellent keynote. You will join us at the panel. So. Just quick word, we're encouraging all the audience to also submit questions using the Q&A function, and we'll try to address as many of them as possible throughout the webinar. Okay, without further ado, I would like to open this panel, and the first question is for Antonio. And in European institutions like ACER, it was mentioned that open source models are being used as reference for policy development, and this is quite a significant statement about the credibility and reliability of these kind of tools. And I would like to ask you, what gives decision makers the confidence that open source tools could meet the rigorous requirements for policymaking at this level?
Yeah, thanks, Rena, and thanks a lot to Agora for inviting me. I'm Antonio Lopez Nicolas, and I'm here in my capacity as head of the Chief Economist Unit in DG Energy, in charge of the energy modeling for DG Energy. Indeed, I think the energy transition is going to go through a major phase now and a major transformation. I mean, we're going to triple renewable energy from now till 2040. We are going to double electrification. We are going to reduce final energy consumption by 1/3, and we are going to reduce fossil fuels by 2/3. So all of those not small things. And the energy transition as such is going to be key for European economy, for its competitiveness, security, and decarbonization. And energy modeling is at the very center of all of this. So we need to underpin our policies with a strong, solid, and reliable energy modeling that brings us forward, that makes our policies sound, and also that makes our policies able to withstand and go through the co-decision negotiations with member states, with the European Parliament, and gets also the support of the society as a whole. So it's very, very important that we get it right. So now, how do we get it right? I think we use at the European Commission a full modeling ecosystem and a combination of notably proprietary models and tools with open source modeling. I think I would use the old quote that all models are wrong, but some are useful. So I think we need to find a complementarity of the different things, and we are very, very happy to see how open source modeling have developed over the last few years, and thanks to your good work. And I think this is playing an increasingly important role in the modeling ecosystem that we are building, that we have developed over the years. But from our perspective, it's important to know that it's not a question of black boxes or white boxes. I think it's a question of making the different available tools complementary, so that the outcome we get out of the modeling is the best possible, and that we get things tested, double check, complemented, and we get an outcome that really informs policy making in the best possible way. So we are very happy with the developments in terms of open source modeling, because we see a promising avenue to complement our existing tools and complement our existing policies. And I think to see it as a kind of more resilient, solid, and future-proof modeling ecosystem that can help our policies to go through. Yeah. Thank you.
Thank you very much for that. That's great. And indeed, it's about our future in Europe, the decisions that you're making. So it's very important that we get it right. And for that outcome, we want to make sure that the modeling or the outcomes coming out of the models are the best. And allowing the fact checking for those kind of outcomes, I guess open source allows us to do that. So that's really wonderful to hear. Thank you very much. Building on this theme about the underpinning evidence, I guess, and creating that through and ensuring credibility in the outcomes of the models. Here I would like to turn to Tom now from a technical perspective. Where do you see the status of open source modeling with this? What difficulties did you have to overcome in order to reach this same level of capability and trust as the existing models that Antonio mentioned? And are there still some gaps from your perspective?
Yeah, so I guess one thing is you can do very bad modeling or very good modeling with closed tools or with open tools. Like there is everything. So the modeling is somewhat separate from the tools. But I think one important thing we had to demonstrate with the open tools was that you could do very high quality modeling. So over the last 10 years, it's been a very slow process to establish trust by showing that you can get very high quality modeling outcomes that reproduce other studies with the tools. And I think by building up this trust, by demonstrating the studies, by allowing them to be criticized and going through multiple rounds of hazing by all the people who are looking at the models and poking holes in them and asking difficult questions, I think we've established that trust, and that is a very long process, which is why it's taken 10 years. But I think we're at that stage where there is wider trust and acceptance that open source models can deliver that credibility. But it's hard won. I mean, it's gone. We've had to like endure all of this kind of committee feedback processing from different stakeholders to establish those tools. And I'd say it's an ongoing process. I still have, would like to see more validation. I'd like to see open versions of the model reproducing historical data going back 20 years. I mean, that would be something that one could consider improving as this kind of credible validation. But I think we're largely there because we do start to see really institutional take-up because the credibility of these tools is established. And that is really something that we didn't have 5 years ago and didn't really have 10 years ago.
Great. Thank you very much for that. I see that there's a common theme. So to develop these sort of robust outcomes, reliable, credible outputs from the models, that it helps that it's an open source community so that everybody or more people, let's say, have accessibility to this and they can contribute to the discussion. But nevertheless, there's an area where it could be improved in the way of validation and testing, I suppose, different types of scenarios, etc. And so then it brings me to the next question for David. And here I'm wondering from a philanthropic and funders perspective, why do you think open source modeling is important? And to enable these kind of multiple scenarios and validating historical data and having multi-objective optimizations and so on to develop these robust outcomes, there is a lot of computing power that's needed, I guess. And so here, how do you see the funding community also supporting that computing infrastructure need to be able to deliver this?
Yeah, that's a great question. And thank you to the whole Agora team for having me today. I'm here on behalf of my grids team at Breakthrough Energy, and just real quick on our goal. We're trying to make open grid planning accessible globally by 2030. So that's kind of the overarching goal. Now, why are we so interested in open source modeling, and why now? I think Tom Brown really laid out a great set of reasons why open source models are valuable. So I don't want to repeat too much of what he said, but I think basically what we're seeing is that there's an immense amount of capital that needs to be deployed in on the grid and in the energy system wide to both meet rising demands for electricity, things like AI and data center load growth that we've been hearing a lot about in the last few years, as well as to achieve decarbonization goals. So these two macro trends are kind of coming together at once and creating this immense amount of pressure to deploy a lot of resources to reinvent the grid, expand the grid, and we need to do that prudently and efficiently in a way that brings together all the stakeholders that are impacted. And so I think that's where open source models really can foster that debate and understanding across many industries, across the public and private sector, and globally, so between countries. And I think as for the, how philanthropy is interested in computing power and addressing computing barriers, I think that's just one piece of the puzzle, but one that we definitely care a lot about. It's not enough to just make the open source modeling tools available. Obviously, they need to be able to be run easily by a variety of stakeholders. So not just companies that have a lot of resources to throw, but also NGOs, other actors in the public sector. So we are focused on the computing problem, and I think we have a multi-pronged approach right now to address it. So one, we care about advancing the capabilities of open source solvers. So we need to make open solvers, open and free solvers, better so that they can get closer to the performance capabilities of proprietary solvers. So that would help to reduce the computing challenge for open modeling and make it cheaper. We also want to improve tools for helping different parties deploy on-premises compute solutions. So where they want to actually control the compute and not use the cloud, make it really easy for them to set that up. And then we also want to develop affordable cloud compute solutions that are scalable globally. So all three of those approaches are ones we're exploring and trying to push forward at the moment.
Great, thank you. That's really great to hear the different dimensions that you're supporting to advance that capability for open source to develop these robust outcomes. I just got a confirmation that our fourth speaker actually is not able to join. So I have another question, but this one I'm going to ask you to raise your hand, maybe if you're interested to answer. And this one's about, I think one of the often discussed benefits, and it was also mentioned, of open source is the transparency of what is being considered, I suppose, in the planning processes and decision-making processes and making assumptions and so on. And then do you think that transparency has a value even when stakeholders aren't actively challenging the model? And does this, like, just the fact that that you could challenge it if you wanted to, more or less, does this help build trust and make the energy transition decisions more acceptable to the public? Anybody wanting to answer this question? I want to give it a go. Okay, there you go, Tom.
I mean, I think the answer has to be yes. I mean, it does help people build trust, because they know that I know that it's open. I mean, if I publish it openly, I have to really make sure that I stand behind it. So the fact that you really stand behind it as a modeler means you go that extra mile to really make sure all the I's are dotted and the T's are crossed. So they know that I know that they can look at it, and that is enough in some ways to help build up trust, I think, even if people maybe not actively going over it. I know the consultancy sphere well, and there is often a lot of pressure to get things done in deadlines, and some of the reasons you don't want it to be published is because you maybe did cut a few corners there at the last minute. And I mean, we never did that, obviously, but I mean, other people would. And so I think it does help to know that the thing is open, even if you can't look at that. Maybe someone you can, if you're not capable of inspecting the model, you can also then hire somebody else to maybe have a look and try rerunning it. So I think it's already a big step to have that transparency there.
Great, thank you. Antonio and David, unless you want to comment on that.
Yes, of course, happy to do so. I mean, clearly, I mean, I'm not the one who is going to advocate against transparency. I think transparency is crucial for everything we do, and clearly, in that regard, I mean, open source models have this added value. So I think that's a very good feature of those, and this is perhaps one of the key reasons why they are developing so fast and why they are playing an increasingly important role in policymaking. So I think all this is very good. Now, indeed, is not the only way. I mean, being an open source model is not the only way to provide transparency and trust. I remain fully convinced that work with standard proprietary models over the years can provide similar levels of trust through different means and different vehicles. And I think, again, I will stress my previous message that the combination of both, I think, it's what gives strength to the energy modeling ecosystem.
Great, thank you very much.
And I'll just add one really quick thought on that. I think this is a good question because we are hoping to raise engagement across a variety of stakeholders with energy modeling, but just realistically, most stakeholders are not going to be interested in or able to run an open source model themselves from the ground up. And so that's why we're not just focused on my grids team on improving model capabilities and supporting open source tools. We are also interested in decision support tools, so that the tools that can kind of run on after you do your energy system modeling or grid modeling, that help to communicate results more efficiently and clearly to a broader set of stakeholders. So that can include things like making it easier to build interactive dashboards to explore a variety of scenarios and understand trade-offs without having to go under the hood and actually set up a model yourself, or things like advancing the state-of-the-art on modeling to generate alternatives approaches. So you can explore a broader set of the solution space more quickly and kind of do that in an automated fashion so people don't have to understand the underlying math behind it. So we are interested in those kinds of tools as well, and I think that would help address that challenge.
Great, thanks as well for that, David. I wanted to now turn to the last question, which would be one I want to ask to all of you, but I think, David, you already covered a lot of ground, because the question is about what do you think are the key challenges that still remain for open source modeling to become mainstream globally? And I think some of those aspects that you mentioned are already answering that question. But in case you have something in addition, please feel free to jump in. And here I would ask Antonio to answer first, and then Tom, and then David.
Yeah, maybe quickly, my 2 cents to that question, more from a policymaking European perspective, European Commission perspective. I mean, one challenge could be the issue of confidentiality and the fact that sometimes you have to deal with sensitive information. I think that's one important thing that we cannot neglect. Second one is about the sometimes fast-paced environment you need to face in policy making, and the need to have a dedicated workforce. Sometimes you are faced by the situation to develop a very quick analysis to develop a legislative proposal in terms of an energy crisis, for example. And then, I mean, in that case, you might have a challenge to get the things done. So those are two things I would like to flag. But one final message from my side, and it's one of hope and encouragement, because I think what you are doing with this open source modeling is incredibly important for energy modeling and for our future work. So keep doing it like that, because it will have an important contribution in the future for everything we do. So thanks a lot.
Thank you. And how about you, Tom?
I mean, I think I've touched on the validation already, but I would maybe just emphasize that openness can also be supported by legislation. So the European Commission has an open source strategy that encourages open source. And the reasons are manifest. And one thing we haven't touched on is this digital sovereignty, that you get more control over the software. We see lock-in to commercial solutions all across the digital sphere, and open source gives you a lot more control over your data and your software. And that could be written into legislation. We have a grids package coming out on Wednesday, where there is talk in the leaking of a Central European scenario for infrastructure gap identification. And that'd be a very good opportunity to really put the openness front and center in that policymaking. It can go into the regulations and into the directives. So that's one place where we've seen progress in the past, where it's been written into the legislation. And I think this raised awareness now gives us the opportunity to put more mandates into the European legislation. Thank you.
Great. Thanks for that, Tom, for the timely topics as well for European discussion. And then, David, would you have any other points to add?
Sure. Yeah, just real quick, I wanted to go back to Tom Brown's utopic vision, which I really liked the way he laid that out. And I think to achieve this goal of having this broad set of stakeholders, of diverse stakeholders, from industry to academia to government folks, all kind of working together with the same from the same set of tools and data, or at least a much more similar set of tools and data than they are today. I think that's still a monumental challenge. And I think one of the things we're focused on, which is hard work, is actually just building closer and more formalized collaboration structures to bring those different groups of people together and have them all have a stake in the shaping of the overall goal, the tracking of progress, and the actual development of the tools themselves, so that everyone kind of has a stake in the work and are bought into the work. I think that's really important, and it comes back to just like getting the people together. And so there's an incredible organization of people already in the open source development ecosystem, and we're trying to kind of bring in a broader set of folks from industry to philanthropy to government as well. And I think that will be a main focus of our work for the next few years.
Wonderful. Thank you so much indeed. And that's a really great point to end on, and as a segue into the second panel, where we will focus on how to foster that ecosystem more globally. It seems from the first panel that in Europe we have a fairly active, let's say, ecosystem already around the open source community, and some level of accepting those kind of outcomes coming out of these models, that they're credible for policy making, and to translate that across globally. The important thing is to really foster that culture across to different regions. So that's really great point to end on this panel. And I would like to thank very much each of you, Antonio, David, and Tom, for this excellent discussion. And you can also feel free to switch off your cameras now, as I'd like to move on. to the presentation by Agora think tanks. I'll hand over to Samath Kumar, who will present about the PyPSA-SPICE. That's the scenario planning and integrated capacity expansion tool, which is just been released recently.
Thank you, Rina. This is an exciting day for our team. We have been working on this model for some years for internal use and some studies that we did with our partner. So it's great to be finally open sourcing it. It was always the plan to fully open source it, but it just took some time. So SPICE stands for Scenario Planning and Integrated Capacity Expansion. I get asked a lot, why SPICE? Well, our team just decided to have a bit of fun with it in the spirit of Python ecosystem itself. You might know the name of Python itself comes from the creator of Python being a fan of comedy series Monty Python's Flying Circus. So in that spirit, our team really loves spices. We have a shelf full of hot sauces from around the world. So with that, and the acronym fits quite well. So moving on, I will talk about what were our goals with the PyPSA-SPICE, what are the key features, some examples of the studies that we have done using PyPSA-SPICE, and I'll conclude with some comments on modeling activities at Agora. So PyPSA-SPICE has been really designed based on our experience of modeling across different countries across the world and our collaboration with our partners. Of course, the first key goal for PyPSA-SPICE was to have policy relevance. Here we did some studies and focused on deep decarbonization across energy sector. And also during the whole process of development, the features was really informed by the policy questions that we came across. The second important goal for PyPSA-SPICE was capacity building. We worked with various organizations who were looking to build in-house modeling capacity. This is not a no-code solution. You still need minimal amount of coding, but our goal is to build capacity with the institutions, and it can be an entry point into the PyPSA ecosystem. Another very important goal that we had in mind was ownership and modifiability. Tom briefly talked about model sovereignty. So for us working on this model, it was very important that whoever is using this model can fully, completely own the code, the data. They can make decisions about, specifically about data, that which data to open, because sometimes you have restrictions and you cannot open the data. We have given it a permissive license of GPL2, and like no two modeling studies are the same, right? So you need to make, based on the modeling study, some small changes. And that's what we have also tried to do in the framework, that it's easy to make changes, add custom constraints, change your tool of how the output visualization looks like. The final goal for our PyPSA-SPICE framework was to be able to feed custom data. So especially working in a lot of geographies where you don't have a large amount of open data available, the idea is that the institution or the person using the model can easily feed whatever data they have access to. What this also allows us to do is build scenarios and studies which are quite in line with, for example, national energy plans that are released. When we look at the examples, we will see more into this. Talking about the key features of PyPSA-SPICE. So PyPSA-SPICE is a multi-sector cost optimization model with the focus on power sector. It can be used for assessment of national or regional, mid and long-term energy scenarios. The model itself does co-optimization of generation, capacity, interconnection expansion at an hourly resolution, because also with high share of renewables, it's quite important to capture this effect. It has a flexible sectoral coverage. So you can run a base power model and then decide if you want to add transport and industry sector on top of it. We have several predefined custom constraints, which we came across quite often. For example, energy independence for a country, looking at all of the energy consumption in a country. Reserve margin, we have a dynamic and a static implementation of reserve margin. A must-run constraint on thermal generators, and so on. So this is in terms of the features of the framework itself. What we also did a lot of work is on making the workflow of running the model easy to use with the focus on capacity building and feeding custom data. So to give you a very high level overview, it's the way the system works is you define your initial design of the model, like what geographies you want, what technologies, and so on. And you run a script which creates a bunch of empty files, and then you can fill in your data, run, and then do the analysis. For the analysis also, we found that using, for example, typically Jupyter notebooks might be a bit difficult. So we decided to build a small visualization tool, which you can use to compare scenarios. Everything is run locally, so everything is on your computer, and you can have a tool where you can compare across scenarios. We have also put quite a lot of effort on documenting in detail what the model does, what are its limitations, and you can find quite detailed documentation. Yeah. So let's look at some of the studies that have used PyPSA-SPICE. One of the first studies we used PyPSA-SPICE was for Thailand. This was done in partnership with several local partners, and this was part of a case program. The focus was to really model the whole energy system and create national long-term scenarios for complete decarbonization of Thai system. In the study itself, we used 4 different models, and PyPSA-SPICE provided a big chunk of the analysis on the supply side. We have another similar study that is led by ICSC, who is Romel is here, and we will hear from him next in the next panel. And this study is also developing similarly long-term energy scenarios for Philippines. The 3 studies in the bottom are power sector focused. Here, for example, the first study, we analyzed Thailand's PDP, Power Development Plan. And what was important here was that the PDP was released, and then there was like a 1-month time frame to give comments. So that means quite short time. So our model's flexibility to feed custom data from the PDP reports into the model so that we have scenarios which are in line with PDP so that we can do comparison was quite useful. Similarly, we did another analysis for Vietnam, looking at its PDP and seeing how it matches or does not match with the JETP commitments. We have another study that we did on Kazakhstan, looking at Kazakhstan's power system in 2035. So yeah, we have used this framework for several studies, targeting like very specific research questions in mind. Some comments on Agora's modeling activities. So I want to be very explicit and clear. PyPSA-SPICE is just one tool, and the modeling at Agora is fundamentally collaborative. We collaborate with partners with bringing in diverse set of modeling frameworks and tools that really fit the project needs. And we are also working to promote open source modeling ecosystem. To just give you, the majority of studies at Agora, like continue to use other frameworks than PyPSA-SPICE. To just give you an example of like some very recent work that is recently published or about to be published. Tom also mentioned this in his keynote. We just recently published a European model which has several grids, including electricity grids, carbon grids, hydrogen grids. It's quite a very cool model, actually. Built on top of PyPSA EUR by Fraunhofer, and we are working with OET to fully open source it and to also be able to maintain it and increase its usability for the community. The second one, it's not a modeling study itself, but it's a guide that we are about to publish. Agora Industry will publish on how to go about modeling P2X for long-term energy planning. Even within a country where we have used, for example, PyPSA-SPICE, we continue to work with other frameworks. So, for example, in the Philippines, again led by ICSC, there's a study on efficient integration of wind and solar power in the Philippines. Here, Transition Zero helped develop the model for it. Finally, I want to briefly talk about our close collaboration that we do with INET. INET is for International Network for Energy Transition think tank. And our goal is really to promote open source modeling. Just a couple of weeks back, I was supporting an INET training on PyPSA, the framework itself. And during the training, what I found really cool was that we had these 2 days of hackathon, and each team built for their country a small model using PyPSA, which was really custom to answer that specific research question. So it was a small model, but really answering a targeted question. I think this is also what flexibility like open source, flexibility that open source frameworks like PyPSA provide, that you can really shape it into what exactly your research question or goals are. Tom also mentioned this in his keynote, but I just a couple of weeks back had this experience and I found it like really, really inspiring. So to conclude, while we will continue to maintain and develop PyPSA-SPICE, we will continue to collaborate with a lot of other institutes and other modeling frameworks. Our goal really is to match the best tool for the best use case. I would like to end by showing a stylized technology adoption curve. Maybe you know it. We have in the beginning innovators like Tom Brown, who lay the groundwork for innovation and building this, getting the technology ready for adoption. But today, as we see, there is several organizations who are centered around open source modeling. To me, this shows that we are really ready to go up this curve of technology adoption. And I think this is a correct time to support open source modeling, as it can really help bring transparency, innovation, and collaboration in energy planning, as we heard from other speakers also. So yeah, thanks a lot, everyone, for your time. You can check out the documentation, the GitHub repo, and you can also join the discussion to suggest new features or bugs or report any bugs in the model. I look forward to the next discussion on how we can build and promote further this open source modeling ecosystem. To you, Rena.
Thank you very much, Samath, for that excellent introduction to PyPSA-SPICE. I hope the audience is now motivated to try it. And I really like the inflection point graph. I was always thinking of it as the crossing the chasm. I guess it's a similar concept, right? how do we get now from the early adopters to really global majority mainstream. So I'm really excited to bring us to the second panel to focus on this point. Thank you. The second panel will be focusing on building an open source modeling ecosystem. And the question here is, how do we move ahead? Again, we have a bit of limited time, around 20 minutes, and 4 panelists. Just a quick recap. In our first panel, we set the scene that open source models are mature and reliable to support policy decisions. And there are aspects that still need to be tackled. And it's important to now foster a community and ecosystem to continue the development and wider adoption. So here in the second panel, we want to explore more concretely then what are the actions that are necessary to create this community, and how can we better work together to address the challenges. So let me introduce our panelists, and it would be great if you can turn on the cameras as well. There will be Dr. Marta Maria Fritztaki, the co-founder and head of energy system modeling at Open Energy Transition in Berlin. Open Energy Transition is doing pioneering work with ACER, as it was mentioned, on the flexibility assessment, and developing an open source version of the TYNDP model as well for Europe. Marta represents the new generation of organizations built around open source as a concept. And then a second will be Mr. Matt Gray, who is the CEO and co-founder of Transition Zero in London. Transition Zero delivers open access datasets and is developing also a scenario builder, a no-code solution to democratize access to modeling. And he brings the entrepreneurial perspective on building sustainable open source businesses as well. The third panelist is Mr. Anthony Vautrin from the International Energy Agency in Paris. He's an energy modeler there working on the World Energy Outlook. And he can speak to how a major international organization like the IEA is thinking about open source modeling and data. And the fourth panelist is Mr. Roberto Emilio Hernandez, or Romil, as he asked us to call him. He's the Director for Energy Policy at the Institute for Climate and Sustainable Cities in Manila, ICSC. And he has used this PyPSA-SPICE that was introduced by Samath to develop long-term energy scenarios for Philippines. Thank you for staying up late and joining from afar as well. Okay. So without further ado, we'll get started with the second panel. And here I want to start the first question with Marta, with a fundamental question. What does it mean to have a robust open source modeling ecosystem? Here we're thinking not just about software, but the community, maybe standards, training, funding mechanisms, etc. We would like to hear from you first.
Yeah, thanks for the question. Very important one, of course. I think most of the things were already answered during the first panel and during some of the presentations. But yeah, for robustness in the energy system modeling domain, I think we need like really full reproducibility in the modeling system. So starting from the data, but also going through the code and versioning of packages and workflows, so that we are like anyone should be able to run, but also to rerun a study to get the same results, so that, you know, bugs can be traced later or assumptions can be even changed later, and we can then maybe run some sensitivities analysis also retrospective to see whether our decisions were correct or maybe why they were incorrect in case things, you know, change. But that's only for the modeling pipeline. You also asked about like the whole community. So I think if you're a modeler and running the model, like the assumptions that all the model assumptions that go into the model need to be also traceable and transparent, and also, you know, you should be able to to extract the assumptions easily from the model and see what actually went into the model. For instance, if a model is customized and then later on, if you go to the GitHub, like it's a huge package and it's really difficult to see sometimes where a certain assumption was put. So I think it would be really necessary to also see, to have a robust model, what was actually put into the model. I think digital sovereignty was also already mentioned, so that we don't depend on proprietary solutions, but are really independent on our choices, on the consultant, on the tool that we are using. So yeah, I think that also goes into robustness, because I mean, if you're able to use a tool for a decade and then something changes, like the tool is no longer supported by like one vendor, what do you do next? Like that's also a part of robustness in that sense. And I think lastly, of course, for robustness is longevity of the tools. So it doesn't exist for like a couple of years, but it is actually there for a very long time. And there the key word is, of course, funding. And funding comes not from one pillar only. It started in our case mostly from research funding, and now it's really going into the philanthropic funding case. But I think the next pillar is really industry adoption, because this is also like a huge potential, yeah, funding opportunity for the open source solutions that ensure longevity, so that we are still there in a couple of years and there is still yeah, funding available to maintain the tools and to build the tools in a direction they are actually needed. So I think all of that parts, I know I answered with many separate items, but I think all of that really plays a big role for robustness in the ecosystem.
Great, thank you so much. It's good to hear all the different components that you think are important here. And I would like to come back to you later on another question about, given all of that, how you see building a business model yourself based off of open source. But before I get there, I'd like to go first to Romil, who's a recent user of PyPSA and a tool that's based out of this. And so, are you here? I don't see you currently. I just want to make sure that he's here.
I'm here.
Okay, great. Thank you. So yeah, my question for you is that as a user of a tool that's been developed and just presented by Samarth as well, what was the experience, I guess? What did you find was most valuable, and what support did you need from the developer community, if anything, and the partner to make sure that it worked?
Yeah, thank you, Rena, for that question. I think exploring the open source modeling approach, especially in the context of energy planning and building climate resilient programs, both at the national and subnational levels in the Philippines, is driven by the crucial need for collaboration and transparency. Proprietary tools like Plexos, while it's very powerful, often have license restrictions, specifically costly subscription fees. This means only a limited number of experts and organizations can access and work with them. This exclusivity creates barriers for a huge number of experts from the national government agencies down to local government units and state colleges and universities, which typically have limited budgets and capacity, especially in a country like the Philippines, which is a third world country, or rather a developing country. So restricting our ability to independently analyze and play a role in planning for local energy futures, for the futures of Filipinos. So open source modeling breaks down these barriers by enabling participation from broader stakeholders from the national government agencies and subnational actors such as municipal and provincial development planners, engineers, policy officers, and even civil society and academic partners. So it empowers most of these groups to directly engage with the models without costly licenses or proprietary constraints. This openness results in knowledge sharing among municipalities and agencies, think tanks, and the academe, accelerating capacity building and institutional learning across regions in the Philippines, and thus more aligned national and subnational sustainable development programs. Further, open source models promote transparency, which is vital in local governance. I think I won't be expounding too much on what's happening in the country right now when it comes to governance and accountability. So when subnational government units adopt openly accessible tools, their work can be reviewed, validated, and improved by the community of experts. This collective scrutiny builds trust, helps ensure more reliable results because of the participatory nature of validating the results, and supports evidence-based decision-making for climate resilience and energy transition strategies that are closely aligned with the local needs and priorities. So exploring open source modeling at the national and subnational level is about democratizing access to technical tools, encouraging collaborative problem solving, and building sustainable local expertise to shape a more inclusive and transparent energy transition across the country.
Great, thank you so much for that. Indeed, it gives the opportunity, I guess, to have a wider group of stakeholders involved in the discussion, and it is really a great aspect of adopting open source modeling. With that, I'll move over now to Matt from Transition Zero. And when we're talking about this capacity or capability to, so accessing the tool is one thing, but using the tool wisely to be able to answer the questions that you have, right, is another thing. And so there, what role does capacity building and training play? And is there enough of this to make the software usable in the way that it's intended?
No, thank you for the question, and thank you for the invitation to this event. Firstly, I'd just like to congratulate Agora colleagues for the release of SPICE. I love the name of the package. I'm a little jealous of the name. And also it was great to collaborate with Agora and ICSC this year on the development of a PyPSA model for the Philippines. We look forward to uploading SPICE to Scenario Builder, our no-code platform. For those of you who don't know Transition Zero, we are a climate tech not-for-profit focused on no-code grid modeling for energy transition planning. So we develop and use open source packages such as OSeMOSYS and PyPSA and make them available via our no-code platform, which is free and highly accessible. I guess to answer your question, obviously like capacity building and training is vitally important. Capacity building and training, I see them as the bridge between open source availability and real world use. So they reduce setup times and skills barriers, build confidence in results, and create local champions who can then support and train others. And I think that's the virtuous circle of a thriving open source community. And it's particularly important in emerging markets and developing economies, which is where Transition Zero spends a lot of its time. And the reason it's important there is because open source modeling, I would say, is less mature. So users, particularly those users in government and industry who have historically relied on commercial and closed source modeling packages, need to be convinced that there are credible open source alternatives out there. I think for a lot of emerging markets and developing economies, we're not quite there yet, but I'm confident we'll get there within 3 years. And Transition Zero is excited to collaborate with everyone on this webinar to make that happen.
Thank you very much, Matt. I would like to now move over to Anthony as well from the International Energy Agency. And here, touching on or extending from again the fact that open source tools and the support allows open discussion, but the data that goes into the tools is also quite important, as we all know, garbage in, garbage out, right? And energy data may not be accessible or even available sometimes, especially for future scenarios. And so here, a concern we hear sometimes is about the proprietary data or the data quality. And how do you deal with this when we're using open source models?
Yes, thanks very much, Rina. So to give a bit of background, we do move towards open source at the IEA. Tom introduced it very nicely, actually. We are users of PyPSA since 3 years now. Of course, we've got like internal models, but we wanted to develop something new for hourly analysis as the emphasis on electricity security was getting stronger, for instance. So maybe to give a bit of background, we chose PyPSA actually for its openness. So of course, knowing all the equations, what's in the background, for its flexibility actually, because we had different scopes of analysis. For instance, one stronger on demand flexibility, so we needed to improve to adjust a bit the model on some dimensions. So that was very precious with PyPSA. And eventually for its very large community, which proves very useful at the beginning, we're mentioning capacity building. Well, the community helps a lot. So that was great. And it allowed to make some of the studies that, that Tom mentioned earlier. I think those would have proven very difficult, very challenging at least, otherwise. And we are also, so that's how we use open source somehow, but we're also trying to engage a bit more with the community and to contribute to open source. So actually our models are not necessarily all published, but they are heavily documented. All the equations, 150 pages of documentation for the model we use for the World Energy Outlook. So that's an attempt at least to move towards more transparency. And we do publish some of the models on our GitLab page. Or methane abutment, one was published around 6 months ago, actually. So that's for the big picture. But actually, as you said, Rena, one huge issue is actually on the data side. And we, as the IEA, face that data issue first as like energy modelers. We need data, but also as, well, a major institution that produces such data. We do collect a lot of data ourselves, plus we get some from the governments, from companies, from other institutions. So we do somehow sit on a lot of data. To be very transparent, of course, there is an issue with that data stream somehow, because it's a large share of our revenue. So as the IEA, with the current financial structure that we have, all the outputs cannot be published as such, again, considering status quo here. But that being said, we still try to engage towards more publication and transparency. So for instance, almost all of the inputs that we use are being published. So all the drivers for energy demand, or all the assumptions that we make, we were mentioning assumptions a bit earlier, that are being published for scrutiny, for feedback also. The techno-economic assumptions for power generation, the transformation sector. So there is an attempt to publish more, and all that data is freely available on our website. On the data production point of view, so of course, as we said, we cannot publish everything, but we still try to improve the transparency for the global energy community, and all the major outputs from our models are also published, not only in the book itself, but also with data sets on the website.
Great, thank you very much, Anthony, for that. And yeah, I'm sure the modeling community would really love to have access to the data that the IEA has and also develops, as it's a global benchmark for a lot of the analysis that is done. So we look forward to continuing working together with the IEA. Thank you. I would now like to circle back to Marta again to the question I hinted at before. So I think throughout the two panels, there's been quite some evidence that there's a lot of benefits of open source modeling, and there are a number of keen adopters as well. But there's also evident that there are aspects that need to be still addressed, and we still need to cross that chasm or go through that inflection point. And so as a co-founder of Open Energy Transition, which is a business, I suppose, centered around open source modeling, what gave you confidence that this business model would work? And how do you make open source sustainable as a business?
Yeah, thanks also for this question. Yeah, I think, I mean, I guess there's never certainty when you start a new business at the beginning, so there's always uncertainty around whether what you're doing will be successful or not. But I think during my time as a PhD student, and I think that also holds true for my other co-founders when we were still working with Tom Brown on open energy system modeling and the PyPSA universe and ecosystem, we already saw a lot of interest from the industry for private consultancy, but we didn't want to make the open source community a consultancy really, just based on, yeah, we just provide consultancy services and then that goes somehow into the void. So we wanted to create something that's sustainable for like the bigger community and also helps the industry players to adopt open source solutions. where we try. That's actually something that Tom said also during my time as a PhD student. How can we make institutions contribute back to the open source ecosystem? And we are trying to really enhance this back contributions from industry players back to the whole open source ecosystem through getting funding. That's also what I said before, like by funding an open source ecosystem, we can really make contributions back. And yeah, if you're still here, Tom, I hope we are not overloading you with pull requests at the moment, or try to find a solution for that. But I think the key answer here is always getting funding from the also from the industry players and make back contributions. And I think that played out quite okay at the moment. We are growing. We see an increased number of contributions from the industry also back to the open source ecosystem. And I think that was more of a hope rather than real confidence. But now it's getting more in the direction of a strong open source community.
Great, thank you so much. I heard the critical word funding a lot. So I'll use that as a hint for the last question or the last round for comments. Perhaps 1 minute per panel speaker to answer this. And if you had the funding, right, what action would you take tomorrow personally or from your company as part of the community to bring this ecosystem further? I'll go with Matt, Anthony, Romil, and Martin.
Yeah, so maybe I'll answer the question at a high level. I think there's 3 aspects to this. There is the model packages themselves. We have quite a lot of model packages, and as we've found out today, they're becoming increasingly important and relevant. Then I think below the model packages, we have a series of foundational components that need to be built in a very scalable and productionized way to make the use of those model packages easier. And then at the very top of the model packages, we have like no-code tooling to bring in wider audiences, those who can't code and never will, which frankly is the vast majority of the energy sector, to ensure that these models are used by the greatest number of people possible. That's sort of what I would do if I had unlimited resources.
Excellent, thank you. Anthony?
Sure. So I think from our perspective, we see very good momentum on the model publication side. There is more that needs to be done on the data publication side for us as the IEA, of course, because of what we just discussed before, but from also like over institutional organizations, from governments, from companies.
Great, thank you. And Romil?
Yeah. While a lot of funding has already gone into research and studies globally, I think the localized capacity building and infrastructure side hasn't received the same attention. So there is a need to strengthen skills through training and investing in the IT systems or servers needed to run these tools to create a more resilient and sustainable ecosystem. These are the areas that allow open source models to take root, especially in developing countries like the Philippines, and be used confidently by local institutions. To optimally utilize available finance for enabling an open source modeling ecosystem, especially in the context of national government agencies and local government units and other subnational actors, the focus should shift from predominantly funding global research to investing strategically in localized capacity building infrastructure development. Capacity building, Agora and ICSE have already started capacitating a number of planners, energy planners from the Ministry of Energy. But we shouldn't stop there. I think we should continue to help capacitate, as I've mentioned, subnational actors such as local municipal development officers, academic institutions, and other think tanks, local think tanks, so that they can contribute to enriching and further developing our the robustness rather of these models.
Wonderful, thank you for complementing that. And then the last word will be for Marta.
Yeah, I think most was already said. I guess with unlimited resources, I think really building capacity is the key word. We have not enough capacity, and many projects or many modeling studies require just a lot of know-how. And I think we need more people with excellent knowledge in that domain to avoid mistakes and improve the models. Ideally, make them all, then contribute back. Yeah, I think that's
Great. Thank you so much. Thank you, everybody. Thank you, Marta, Matt, Anthony, and Romy for those inspiring calls to action. And with that, I would like to close also the second panel. So a big round of applause. I think what's clear from both panels is that open source models are mature, they're reliable, and the ecosystem is growing. And building this further will require collaboration across all of us, including research community, civil society, international organization, and the private sector. So now I would like to hand over to Dimitri Pessia again for closing remarks.
Yeah. Thanks a lot, Rena. Thanks to all. Actually, you already closed somehow this very interesting discussion, so I will not repeat anything. I just want to thank all the speakers and panelists. And I think this is a very interesting moment, actually, to think how we can collectively pool our resources together to ultimately influence and ensure that policy choice are reflecting the complexity of the power system transformation, of the integration of the power system with the broader energy sector, and how a modeling tool play a key role in this context. And so it's really about building an ecosystem. It's increased the usability of models. It's strengthening the enabling environment. So also non-technician can make best use of these tools. It's being able to communicate around that. It's developing more training, improve the data validation process, and overall the transparency on data access. And I think there is also technical aspects with advancing capability of solvers, ensuring we have enough funding and attract ultimately industry adoption of those tools. But overall, I think no single organization can do this alone. It's really much a collaborative endeavor, and it is really at the core of collaboration with open source tools. So success will depend on strong alliances. The stakeholders which were brought today in this call are part of the broader ecosystem that we would like to continue to actually support. And once again, thanks to everyone for your time, your insights, and your commitment. I'm really much looking forward to building and continuing this discussion with you for a transparent and sustainable future. Thanks again.